everyone, this is Cloud Dragon Podcast, and today I'm going to talk about how to correct implement state machines in the backend. The reason I want to talk about this is because everything we do is just tossing the data around, setting a certain status and updating the state of an object. For example, if we have an order, we set its status to delivered and we modify certain fields. The logic in the application could be anything. It's kind of a black box for us. It could be written in Java, in Go, in .NET, whatever. We just know that when the order comes in, something changes in the database. And so the most work we do as developers is to ensure then that the values in the database change accordingly. So everything we do in the backend kind of has a state, and it's pretty much tied to the business process that the state describes. So it would be, we would have orders, we would have users, transactions, etc., etc. So what we would have in the database would pretty much map onto the business process itself. That's why it's very important to talk about this topic today, because it's not just about statuses, it's about how we communicate about the application to the customers, to the business, and to other developers. If we make this state management incorrectly, well, we would have a lot of problems just from the design itself. And if the design is wrong, well, we would have a deadline not in 3 months, but in 3 years. Even simplest applications, if they are designed improperly, could make development a total disaster and make it really hard to do anything with it. Most of the problems lying in this design is that these are the problems that you can't just fix by a bug fix. For example, you have a corrupted data in the database, you have some concurrent operations that are unhandled, and you don't know why you have a certain data in the database and why the business logic doesn't work as it should work. So these are all obscure issues that are very hard to catch and very hard to fix. So the design of the state transitions is incredibly important, and today I'm going to show you how to properly design it, how to implement it on the database level, and how to monitor the states in general. So first thing you need to know that from the developer's perspective, we just have two types of states. We have states that are kind of normal and simple, and we have states for continuous operations like processing, uploading, basically for external actions that are unsafe in nature, that could take a lot of time and that cannot be executed in parallel and that can't be safely retried. I use simple language for normal statuses, something that is already finished, so it usually, I use simple tense here, and for something that could fail, I use continuous tense. Here is an example of business process for a simple pizza venue, and you see that I just picked random 3 business entities here, and you see that every business entity of the pizza venue has certain status attached to that. When you map out all the business processes for all data structures that you will have in your application, you will much better understand what is the complexity level of application and how each business entity kind of communicates with each other. The main reason why you want to lay out the diagram for your application is to identify unsafe transitions. For example, refund, payments, delivery, or some other stuff that is unsafe in nature, that can be executed in parallel, that can take hours or days to complete, and you can just retry it, is an unsafe operation. You can't retry a payment because maybe it was already paid. You can't retry delivery because maybe you lost a package or it was already delivered. So all these kind of unsafe transitions from one status to another, you have to add an intermediate status here. And the reason for that, I will go to this a bit later in the presentation. But from the design perspective, you just want to make sure that every transition that you are not sure if it could be simply moved from one status to another, and it could be retried and it could be safe. If you don't know that it's safe, you have to add additional status here. So on the diagram here, the cooking, delivering, and paying would be unsafe operations, but the rest of the operation would be safe because I could just simply retry it and move it from one status to another. Once you've identified all these safe and unsafe statuses and safe and unsafe transitions, you could take the safe transitions and just merge them. Because every step here could be safely retried and it could be executed in parallel, and it finishes, let's say, in a few seconds, I could just make it one action. So after you mapped out your business process, you could simplify it by removing unnecessary statuses that exist for a few seconds and they are kind of safe in nature. You also want to identify if you have multiple status for the same entity in your diagram. For example, you may have a transaction and it could have two statuses, one for payment and another one for notifications, and you want to explicitly specify visually how those two statuses correspond to each other. For example, here they are completely independent, so when another developer looks at this chart, he will understand that these are not related to each other. Any business person or user or customer, they will look at this chart and will understand, oh, this is a payment, this is a notification, they are not related to each other. The only thing that unites them is this ID of this object, let's say. And if they see a diagram like this, they will understand, oh, this status is related to this one. It makes sense, why transaction behaves in this way. If you don't specify that, you leave an ambiguity that could cause a lot of issues communicating about this with other people. When you have this diagram, it's not just, a picture. You have to annotate it with a certain information. You have to specify for each status what this status means, what fields of the entity would have to be filled in during this status. For example, for created, it's just 3 fields. For approved, it's going to be 5 fields. And for some other status, more fields could be added, but you would have to specify which fields are valid during which status. This makes supporting really, really easy because you could just look at this documentation and know at which point of time you have this information available to you. You have to also specify how much time each operation can take, because, for example, how much time transaction can be created. 1 minute, 1 week, 1 month, how fast it could be approved, because that could drive your decision making related to architecture of how you would store this at all. For every transition between two statuses, let's say you have status A and you have status B, and you have 5 transitions between those statuses, one by HTTP call, another by timer, the third by webhook, whatever. You have to specify each transition and tell how one status, you have to describe all the ways one status could go into the other status. It kind of serves as a user story here. It's created, then it's gonna approved, now it's somebody gonna approve it, now it's approved. So you already kind of show how this happens without people having to guess what the arrow means. So this is just a visual representation of it, the arrows and the boxes, but each box and arrow have to have a description what it is. If it's a transition, if it's a user event, if it's a webhook, if it's a timer, whatever, you have to specify each arrow what it means. In the code, don't implement finished state machine patterns, frameworks, whatever. Don't use them. It's useless. It's dumb. Just have a list of statuses in your application, and you have a state that contains this status. And you have to make sure that you have a certain status dedicated to to a default one. So you have a default status that is invalid in its nature. It's unknown, invalid, unset, whatever. So it has to explicitly describe you that it's invalid value. It's very important because when I see, in this example, if I see that the status, for example, is created and it's a it's a default status, I don't know if it was really created or it's just an empty object or somebody just forgot to set status and it's a default status. It makes everything much more complicated to understand. So there is so it hinders the trust between developers. So just introduce another status and don't show it on a diagram. It's just going to hold an invalid value here. It will make your life much more easier. You will know that if you have a certain status, somebody has set it and it's somewhere in the code. You could search for it. You know that it's a real status. It's not some default value here. Now I will go back to the unsafe transitions we had, and I will go deeply into how you manage these transitions on the database level, because it's very important to manage concurrency right here. So when we add additional status in the middle between two statuses here to indicate an unsafe transition, what we are trying to do is to make sure that this status transition happens in a singleton. It happens just by one process. And the second thing we want to ensure is we want to indicate that this action has already tried to be executed. So it's not just enough to have a certain distributed lock and move one status A to status B, because even though it may be executed in a singleton, you don't know if the operation was already attempted. When you have a status transition like this, you don't need a distributed lock system. You could use a database as a locking mechanism here. You update one status to another one, and you have a optimistic concurrency update. And if two threads try to update status A to status B, only one succeeds, and this process could continue execution and move status from one place to another one. Here, it's very tempting to leave it like this and just move one status to another, and just if something fails, you have a background process that just checks the refunding transactions and everything works great. However, it's not a completely safe implementation. And the reason for that is that when this process fails and you have a retry mechanism, you need to ensure that the retry doesn't happen right after the transaction moved from one status to another. For example, you have one thread moving transaction from approved to processing, and as soon as it moves to processing, you have a background process that picks it up and tries to recover it. It's wrong. It's not going to work. So you have to lock the let's say transaction, locks the state for a certain time. So you need to ensure that nobody within a certain time period is going to touch this state, at least not try to move from this status to this status. And in SQL, it's very simple. We have a transaction, and when we inside transaction, we just check if a certain time has already passed since the last execution of this transition. And when we lock the transaction, we specify the time that the lock was made, So it means that if some other process tries to execute exactly the same SQL statement here and tries to apply the same logic here, it will not succeed until a certain time has passed since the last time we tried it. Same stuff could be executed through NoSQL, MongoDB for example, works same way, it's just a different condition here. But the point is here we want to ensure that this processing happens in a singleton. If it's just a processing or if it's a recovery, we don't care. We just lock it for a certain duration, let's say 30 seconds. And then we try to do something about that. For example, if the previous transition was from approved state, we could just process transaction and update it to finished. And if it was already processed, we don't need to do that, we could just update it to finished. Or if we just need to wait a certain time, we could just wait it here. So first lock the transaction for a certain time, and then you have a business logic that manages the transition. For normal statuses, you don't need to do that complex stuff. For normal statuses, you just have a optimistic update. You just say, I want to update this status to this status if the previous status is this one. For SQL, you have a transaction. For MongoDB, you just have an update statement. And if some other thread tries to do that in parallel, you just retry it using the optimistic concurrency pattern. It's typically called dirty write stuff, that if I try to update this status to this status and this status has already changed, well, I would have to read the database again, see what is the new status, and can I execute the same business operation on the new status again, for example. Now, when we go to this concurrency and we go into this kind of situation when a certain operation may fail, we need to make sure that we clearly describe the failure scenarios and failure modes of the business process. So so the high-level failures, we should put them in the status itself. So we should have a status called failed, and it should mean something, and there is a description to it, and it's, for example, visible by user, and there is a whole business process for recovering it, or it's a final status, whatever. So some of the errors happening in your application are defined by status. So they are kind of on a business logic level. Some of the errors, they are kind of validation in nature. So they are not shown in the business diagram. They are kind of validation errors, duplicate errors, concurrent update errors, whatever. They kind of they're kind of technical in your API. The user doesn't see them. The user sees only this status. And you also have errors that are not returned by you. They could just happen. A timeout could happen, or a server could crash and you don't return anything. You also have those kind of errors. And you need to specify for the developers, front-end developers, back-end developers, whoever is using your API, you have to specify what they should do in a certain situation. For example, if you have a status failed, this is what you should do. If you have status duplicate, this is what you should do. If you have a status concurrent update, this is what you should do. If you have a connectivity error, this is how you recover. So you have to specify, how every error is going to be handled from the point of user. It's not enough just to specify, oh, this is a concurrent update error. In the, every error that happens, you have to specify, what the person should do about it. Because if you have two errors with a different name, but the user has to do the same stuff to handle them, you could just make it one error. Or if you have one error, but you have two situations when in one case user should do one thing and in another case user should do another thing, you should have 2 errors for that. So the error is not a description of error per se, it's a description of what the user should do with it. Once you have everything working, let's say we have designed the diagram, we have coded it properly, we don't have concurrency issues, everything is great. Now you should have add monitoring to it, because the monitoring of these status transitions and the business process is actually the monitoring everybody would ask for you. For example, a business stakeholder will come to you and say, I want to know how much transactions I have in processing state, or how much transactions get failed to invalid CVV code, or how much money we have deposited, or how much time it takes to approve transaction by person. So all these things that business typically asks are going to be related to statuses. So that's why you want to monitor this kind of from the beginning. First, it makes sense to monitor this because some of these transitions may stack, especially these transient statuses. Maybe you have a background process that is not working and not recovering transactions. You need to know that ahead of time, not 3 months later. So in your database, you need to know that all the transactions are in proper statuses, and each status takes exactly the time you have specified for it. If you say that no transaction should stay in created for longer than 1 minute, well, you query the database and you check it out. How you do it, it's up to you. You could do it in real time, you could create indexes, you could create counters, whatever, but practically you want to have just an aggregation once a day, 2 times a day, something like that, because if something is wrong with status transitions and it's something that was not found, it's not in logs and it's not in monitoring already, you probably could wait for another day to come up to your work in the morning and see that, oh, you have too much transactions in a certain status. Because if you get notified about this at 2 a.m. when it happens, it's not useful because you're not going to wake up at 2 a.m. and start fixing some database issues or transactions in the wrong status. You could always do it in the morning. So it makes sense to just monitor this on a daily basis rather than doing this real time, unless there is a business requirement to do that. And you want to monitor each transition that happens between your statuses, because the transactions may go to the failed status, and that's a normal business process, so you might think that everything's okay. But if transaction percentage that is failed is kind of huge, it means something is wrong with the business logic or parameters or fraud or whatever that causes a lot of transactions not to be accepted. Or I mean, you may have your own business process. For example, you have a pizza delivery and you see that a lot of pizzas are not delivered for a certain reason, like more than 10% of pizzas gets rejected, and you say, well, why that happens? Is it pizza delivery guy fraud, or customers are not satisfied? So these transitions, you want to monitor them because they are key metrics for the business process itself. So this is the last slide, and I'm very glad you made it to this point. You might ask, you explained all this stuff about this business processes. I don't know, why should I do that at all? Like it sounds complex. It sounds like I have to waste, a day on the design of this application. Why do I need to waste my time? First of all, it's not a waste of time, because when you have this process outlined, you already have a documentation for your application. It's a user documentation showing the status transitions. It's a documentation to developers these are the statuses, this is how they work, this is, you have all explanation basically of how application works. All the use cases are going to be covered by this status transition diagram. If somebody from business wants to know how your application works, you could show them diagram and it will explain them the business operation of it. And you also would, if you have the monitoring, you already have a key KPIs for the business. Even if though they didn't ask for these KPIs yet, you already have them because you record all the transitions that happen and you know how much time transaction stays in the certain status. So it's very helpful to have this data in advance, because if you want to add this later, well, it may be problematic. Another thing, so at a minimum you would have a documentation here. And if you follow the second part of it, if you follow the guidelines I've put for the updating of the statuses and making unsafe operations safe, you would get a correct software, which means, well, you just have applications that works. You don't have double refunds, you don't have weird logic. You know that every unsafe operation in your process is handled and you know how it happens. And it also ensures the proper architecture for your application, because if you outline all the processes that happen here, you pretty much draw on your architecture. If you have an orders workflow, orders process and status and state, it's a microservice that manages this process, and you just laid out architecture pretty well. Every process is managed by one microservice or service, and that makes that ensures correct implementation of architecture, because you would not split one process between two services. It's not going to work. And the main reason for that, actually, for all this all this exercise, what you would get from it is a lot of time saved personally to you, because when you draw this diagram, you could just send a link to it to everyone. You don't have to tell, this is how my application work to everyone who talks to you. You could just say, hey, take a look at these docs first, and then we're gonna talk, because the documentation kind of describes the whole process, and 90% of questions could be just covered by this transition diagram, and the person may not even need your help because he could just look it up in the documentation. And you don't have to answer these questions like, what if we have this process failing? What if server fails? Or what if database fails? All these shitty discussions about high availability and resiliency, oh my god, you're gonna answer them just with three answers. It's just, well, we're just gonna retry it, or we have a retry mechanism on that, and in terms of, we have this transient status, so we will execute them in a singleton, and third, we will have a recovery mechanism. So basically everything that happens happens unsafe in your application, you already have this answer on how you would handle those corner cases. Because this diagram with transient status and this recovery mechanism we have described, it works equally well if the database fails, if the server fails, if we have a timeout. All the cases are covered by this kind of approach. Whatever happens to the process, like 30 seconds, whatever number of seconds you have, after previous execution, we try to execute it again. We check the status. If it's okay, we we move it to processed. If not, we just try it again in a certain time. And you have monitoring. You can have monitoring over the retries, of course, to see if you have some elevated error responses. So the monitoring part of it is also kind of answered, because you already say, oh, what if something happens in the background? What if background process fails? You already have an answer. You say, oh, we have monitoring for the statuses. So all the typical answers I get, for example, about how my application works, they are answered by this transition diagram. And it's incredibly helpful to, for communication purposes. You could ensure that this page is just going to be one page with documentation. You could share it with all your team, and now all your team kind of is on the same page. They know how the process works, and it makes much more easier to communicate with everyone. You don't have to document the same stuff again and again. One page with the status transitions and the descriptions of all of that is way enough to cover the general kind of the basic docs you need to start working and talking about your application. Thank you very much for listening for this guide. I really hope it's going to be helpful for you. It's not based on some theory I've read on the internet. It's actually what I've experienced myself, and I found out that just following a few basic steps and outlining the status transitions diagrams is super helpful for development. It makes projects to finish pretty fast. I will have more episodes, kind of technical, in the future. I think I would have a 1 month schedule or something like that. So see you in a few future episodes. Bye.